Okay, hello everyone. In a new video. In this one we are going to solve an exercise related to mechanics and the chapters of mechanical actions and equilibrium of a body. This exercise was a previous one in the Breve exams in 2016 second session, third exercise. The title of this exercise is Hooke's law. A spring balance is suspended vertically with its upper end fixed to a support. Its lower end carries a solid S. The spring balance undergoes a compression as shown in figure 1. So they mentioned figure 1, then now we can use it. The curve in figure 2, also they mentioned figure 2, so now we can use it, shows the variation of the magnitude of the tension T exerted by the spring on S as a function of the compression axis of the spring. So here in this curve, the x-axis is labeled by X, in which X represents the compression of the spring, and the y-axis is labeled by the tension T in newtons. So take the value of G to be 10 newtons per kilogram. So here as we can notice that the spring undergoes a compression and not elongation because the spring is placed inside this tube, okay? And the solid S is pulling the spring downward, so it undergoes compression. Now number 1, refer to the graph and complete the table below. So let's redraw the table here. Here we have the tension expressed in Newton and the compression X expressed in centimeters. So the table consists of 3 columns. The given values are given by 1, and for the compression 3, and for the tension 5. So now let's complete this table by another color. Let's say, for example, blue. Now when the tension is given by 1 newtons, so referring to this graph, so this is the point 1 newton, correspond to this point of the curve, which correspond to the compression given by 1 centimeter. So because the unit is included in the first column of this table, so no need to put here an unit for the numbers. Now when the compression is given by 3 centimeters, then graphically this is the value of 3, which corresponds to this point in the curve that has a value of 3 newtons. So this is 3. Now when the tension is given by 5 newtons, so this is 5 newtons corresponding to the value of the tension. This point corresponds to this point on the curve having a value of the compression given by 5 centimeters. So the value in this case is given by 5. Now number 2, Hooke's law is given by the relation that T is equal to Kx, where K is a physical quantity that characterizes the spring. Give the name of K. We know that K represents the stiffness of the spring. So let's say that K represents the stiffness of the spring, or given by the force constant. And now in number 3, calculate its value in SI unit. So we need to calculate the value of K. It's refer here to K. So we need to calculate the value of K for sure using Hooke's law. Then let's say apply Hooke's law. And Hooke's law is given by T is equal to K multiplied by X. Knowing that we are interested in determining the value of K, now constructing the triangle of this formula, T will be at the top, K and X are at the bottom. We are interested in calculating the value of K. So K is given by T divided by X. Now here we can choose one of these columns. So let's choose this column. Then the value of T is given by 3 and the value of X is given by 3. So let's say that T is equal to 3 newtons and the value of x is given by 3 centimeters. Knowing that centimeter is not the SI unit of length, in order to convert from centimeters to meters, we simply divide by 100. So x, which is given by 3 centimeters, so 3 divided by 100, then the value of x is given by 0.03 meters. Then in this case, k is equal to 3 divided by 0.03. Plugging this on the calculator, it will give me 100. Since both t and x are in the SI, so the value of k will be in the SI, which is in newtons per meter. And we can determine the unit of k by referring to this triangle, knowing that t is expressed in newtons and x is expressed in meters, so the unit of k will be newtons per meter. So k is equal to 100 newtons per meter. Then the value of k in this case is given by 100 newtons per meter, and k represents the stiffness of this spring. Now in number 4, S is submitted to two forces, so this is the solid S. T is one of them, name the other force, so the other force is given by the weight, because S for sure it has a mass, then it will be directly subjected to the weight. Now let me make some space. So the name of the other force is given by the weight, W vector. Now number 5, S is at equilibrium. So here we can use the condition of equilibrium. The maximum compression of the spring is x is equal to 6 centimeters. So what does this value represent? It is the maximum compression that the spring can undergo without breaking out or losing elasticity. Now part A, write down the condition of equilibrium. So how do we write this condition? We always start by writing at equilibrium. So always on the left we write the sum of forces acting on the solid S, and they are given by the weight W and the tension T. So W vector plus tension vector is equal to 0 vector. Now moving T vector to the other side of this equation, then it is given by W vector is equal to minus T vector. So the first equation tells us that both forces acting on the solid S, the effect of both forces acting on the solid S cancel in order to give us the 0 vector corresponding for the condition of equilibrium. Whereas the second equation tells us that both forces have the same line of action, the minus sign for the opposite direction, and same magnitude. Now part B, give graphically the magnitude of the corresponding tension. So by the corresponding tension, they mean the tension corresponding to the value of the maximum compression of the spring, which is given by x is equal to 6 centimeters. So in order to determine the value of the maximum tension, we need to know the value of x, which corresponds to the maximum compression. In other words, we need to use the graph. So let's say graphically. Recall that they give half a mark for this statement. Now for x is equal to 6 centimeters, we have, now referring to the graph, this is the value of x corresponding to 6 centimeters. It corresponds to this point on the curve having a value of tension which is given by 6 newtons. So the maximum tension, let's label it by T max, is equal to 6 newtons. Then the maximum tension that this spring can undergoes or be compressed by is given by T max 6 newtons. Let me write here that the value of T max is equal to 6 newtons. And now in part C, deduce the maximum magnitude of the weight that can be measured by the spring balance. And deduce, it means that we need to use the part just previously before. In part B, we have determined T max, and in part A, we have stated or determined the condition of equilibrium. So knowing that this equation tells us same line of action, opposite direction, same magnitude, then let's say we are in part C of number 5. Now because we have that W vector is equal to minus T vector and we are interested in the magnitude, then in magnitude now here we drop down the vectors and we remove the minus sign, so we have that W is equal to T, but knowing that T max is equal to 60 newtons, then the value of the maximum weight is given by 60 newtons as well. This is because W is equal to T. And now in part D, calculate the maximum value of the mass that can be measured, knowing that we have determined the maximum weight, and the mass can be determined from the weight using the following formula, that the weight is equal to m multiplied by g, knowing that we are interested in calculating the value of m. So constructing the triangle of this formula, W will be at the top, m and g are at the bottom, knowing that we are interested in calculating the value of m, which is m max corresponding for W max divided by g, and the value of W max is equal to 60 newtons, then 6 divided by 10. Now plugging this fraction on the calculator, so the maximum mass is given by 0.6. Since W max and g are in the SI, so the value of M max will be in the SI, which is kilograms. Then the maximum mass is given by 0.6 kilograms. Now finally in number 6, a greengrocer cannot use this spring balance to measure 1 kilogram of potato bag. Justify. So here the mass to be measured by using this spring balance is given by 1 kilogram, knowing that the maximum mass that can be measured is given by 0.6 kilograms. Since 1 kilogram is greater than 0.6 kilograms, then in this case the spring balance may break out or it loses its elasticity. Then let's say since the mass to be measured is greater than the maximum mass. This is because 1 kilogram. So 1 kilogram here represent the mass to be measured is greater than the maximum mass, which is given by 0.6 kilograms. Then the spring may break out. And by this we have finished solving this exercise. Hope it was beneficial for you guys out there watching it, and see you soon in another one.